The HECKOR station is located in the center of the city. It's on top of one of the highest buildings in the area. The HECKOR covers almost the whole old city of Heraklion. This part of the city is the most touristic part, and it also includes all the business. We also have a second station. It's called the HECMAS. It's located in a suburb. It's a residential suburb. The reason of these two stations is that we compare the residential data to the data coming from a place with working activities. We do see a lot of difference between these two, because people leave one area to go to the other area and work and come back later in the evening.
We already have 7 years of measurements. In January 2018, the municipality of Heraklion started some initiatives for modifications in the city center. For example, pedestrianization, road closing, traffic regulations, minor planting. We had the data to check and evaluate how did this modification actually alter the CO2 daily patterns or the CO2 fluxes. We observed a reduction to our fluxes 20 or 30% on the monthly averages from the beginning to now.
It is known that about 75% of the global emissions are coming from cities, so it is important to take into account the urban emissions. This part of the Europe and Mediterranean is actually a black spot because there are not so many stations and flag towers, and actually the urban stations are few, even in Europe. It is very important to have stations in urban environments for two reasons. The first is to support urban research, because with these observations we can evaluate and calibrate the urban climate models and emission models. And the second is the policy support to assess the impact of urban interventions on CO2 emissions. This is quite challenging because the urban space is 3D. We have the three-dimensional urban form, and we have different materials. We have several complementary instrumentation beyond the flag towers. For example, we have phenocams, which is related to monitor the vegetation dynamics, for example, the starting of the season or the end of the season, which is directly related to photosynthesis and the carbon sequestrations. And we have also drones who can fly over the stations, assessing the urban form and function. So we need accurate information about the 3D structure of the urban surface, about the material, the cover and the fabric, and about the vegetation distribution. In this case, we take into account the footprint model of our towers. Because the flag tower is not a point measurement. All the instruments are above the mixed layer, so this is representative of the area, huge area around tower. And we need to know all the characteristics of the form and the cover of this area. So we use this drone for this because our space is not flat and is not homogeneous, it's urban, it's 3D and fully anisotropic.